You tap the microphone on your phone and speak a plain English command. Point the servo to 180 degrees. A second later, the hardware moves. That direct translation is the core of the Neuralink app. The software interprets your intent and calls the necessary hardware functions automatically. The architecture relies on an ESP32 microcontroller, a custom Android environment, and a cloud AI provider. Setting up this entire infrastructure requires roughly 3 to 5 hours of configuration to get the system fully operational. Testing the response times requires standard hardware, like a servo motor or a relay connected to the board's GPIO pins. This setup makes the ESP32 an adaptable machine that interprets intent rather than a device limited to hard-coded commands. Step 1 is preparing the physical endpoint. Right now, the ESP32 board is isolated, waiting for a signal to arrive via Bluetooth. Open the Arduino IDE and use the Library Manager to install Arduino JSON to parse data and ESP32 servo to drive the hardware. Bluetooth Low Energy, or BLE, handles the wireless data transfer. This protocol is native to the ESP32 core package, so no separate library is needed. Once the firmware is flashed, the hardware is ready to receive instructions from the Android app. The Android app serves as the localized brain for the project, translating your voice input into machine instructions. Attempting to build the raw GitHub repository as provided will cause an immediate compilation error. The repository is missing several mandatory UI elements. You must build specific structural files by hand that the original creator omitted. First, you must manually generate the missing vector assets. Add icons for the settings menu, microphone, and navigation into the drawable folder. Next, download the ShareTech monofont from Google Fonts and move it into a newly created font resource folder. Finally, you have to resolve the missing files for the chat adapter logic, which handles how messages are displayed in the interface. Use the existing user message template to recreate layout files for AI messages, tool calls, and system notifications. Only after you inject these missing assets will the project successfully build. Reconstructing these files provides a stable vessel for the logic. A crash-free environment is necessary to handle the translation of human voice into hardware execution. Launch the app on your device and navigate to the settings menu. To process logic, the app requires an external API key. This key authenticates your connection to the cloud-based AI model. Choosing a provider is a technical decision. Use a key for Anthropic's Claude or OpenAI's GPT-4o rather than Google's Gemini. Gemini 1.5 Flash does not natively support the function calling architecture needed for hardware control. It relies on a text parsing workaround that frequently drops signals. With the key verified, pair your phone with the ESP32. This handshake establishes the communication line between the interface and the hardware. Samsung device users should watch for dropped connection sequences. Increasing the notification delay times within the Arduino code usually resolves the issue. With the full stack connected, the system functions as an active agent, processing logic in the gap between the phone and the machine. Autonomous mode shifts the system toward machine-initiated action. The hardware can react based on environmental triggers without any human input. In this mode, the ESP32 pulls sensor data, like a temperature reading, and feeds it directly to the AI for analysis. The app executes this cycle every 500 milliseconds. The AI analyzes the data and decides whether or not to trigger a hardware tool. This frequency creates a hidden financial risk. While individual AI prompts are cheap, twice-a-second queries compound into a significant cost spike in a matter of minutes. If you leave autonomous mode active without monitoring it, the continuous API calls will result in rapid, unchecked billing to your account. Use this feature for short windows, such as testing automated safety cutoffs or monitoring a specific environmental change. When AI is granted physical agency through this project, the limiting factor shifts from hardware capability to the literal cost of the model's attention.